Okay, in this video, we're going to be introduced to our next big topic, kind of the main meat of grade 10 math, is parabolas, which are quadratic relations. So for all of grade 9 and the first unit of grade 10, we were looking at straight lines. They would never change directions. They're perfectly straight. They're linear relations. But those don't capture all of the real world, right? So I think in class we talked about the example of a basketball jump shot. It goes up in the air, and then it comes down. You could think about a half pipe for a skateboarder. Anything with gravity, it's going to come up and come down. It's going to change directions. So lines aren't going to cut it anymore. So we're going to use and discuss parabolas instead. So in this video, all I want to do is kind of introduce some of the key vocabulary that we're going to be using throughout the unit. So first of all, we've got parabolas can work one of two ways. They can either open down. So you can kind of think about opening down, however you want to remember that. Maybe it looks like a frown, looks like an arch. So that's opening down. Parabolas can also open up. So these are the two shapes of parabolas that we're going to be looking at. Open up is going to be more like a bowl. You think about it like a smile. You're feeling up, if that helps you remember. Parabolas will only change direction once. Every parabola changes direction once at either the highest point or the lowest point, and we call that point the vertex. So the vertex is that highest point or lowest point on a parabola, so I'm going to call that the vertex. And every parabola is going to have a vertex, and that's the point where it changes directions. Like any point in math class, I can write the vertex as an xy pair. So in graph A, it looks like the vertex has an x value of 3.5 and a y value of, I think, 6. So the vertex always has two coordinates. So if we're describing a vertex, it's just what is the coordinates of the point, the location, where the graph changes direction. So every parabola has a vertex. Now, if the parabola opens down, it has what we call a maximum value. So what that means is this parabola, like a line, is going to go forever in both directions. So it's going to keep going down forever. There's no minimum. It's going to keep getting lower, lower, and lower. But there is a highest point. So the parabola opens down. The highest point it ever reaches, so that's its largest y value, we call the maximum value. So graph A, its maximum value is 6 because the parabola's highest point is at y equals 6. Imagine you're throwing a ball. The highest point it reaches would be 6 meters, let's say. Our y-axis we're often going to be using to measure height. Now, graph B doesn't have a maximum because it's going up forever. So it's going all the way up to positive infinity. It's going forever. So the parabola that opens up doesn't have a maximum, but it will have a minimum. So if the parabola opens up, there's a lowest value. This is the lowest point we ever get to. Another way to say that is, what's the smallest y value? How far down does the parabola go? 0, right? It never goes beneath 0. So our minimum value is 0. That's going to be the smallest y value. And it's always the y value of the vertex. Graph A doesn't have that minimum value because it's going to keep going down forever. One thing to know about parabolas is they are symmetric. So every parabola is going to look the same on both sides of the vertex. You kind of imagine this dashed line being kind of a mirror. And if I look in a mirror, I get the same thing back. It's symmetric. We have a name for that vertical line that runs right through the vertex. We call it the axis of symmetry. You kind of think about it as like a mirror line. We call it axis of symmetry. I don't love writing that out every time. You can just already tell. So I'm going to often refer to that in class as the AOS. So the AOS is that line that runs right through the middle of my parabola. And like any vertical line, it has an equation that's x equals whatever the x coordinate always is. So if you look at any point on this dashed vertical line, the x value is always 3.5. So I just write the equation of that AOS is 3.5. The equation of this AOS is x equals 4. Again, it's always the x coordinate of the vertex. You're going to think, what x value is in the middle of this parabola? So that's our mirror line. Y-intercept is nothing new. A parabola, just like a line, has one y-intercept. And it's where it crosses the y-axis. Intercept just means crosses. I know I'm kind of going back and forth now, up and down on the page. That's when the x value is 0. So in graph A, that happens at 0, 2. In graph B, it looks like it's somewhere in between 3 and 4. I don't know. Let's say 0, 3.5. So that's no different than before. The y-intercept is just where it crosses the y-axis. What is new, x-intercepts we know are places where we cross the x-axis. Where is y 0? Some parabolas are going to have more than one x-axis. So this one's got, more than one x-intercept. This one has 2. So it's now possible, and this was never possible with lines, that I could have multiple x-intercepts. In this case, it crosses that x-axis at -1. And then it crosses again at, I think it's 8, 6, 7, 8. So I've actually got 2 x-intercepts. So some parabolas are going to have 2 x-intercepts. A line can only have 1 because a line never changes directions. It never comes back. A parabola can have 2 because it changes direction once. It's never going to have more than 2 because I'm never going to change again. We're not looking at waves or squigglies. It just changes direction once. A parabola doesn't have to have 2 x-intercepts. If you look at graph B, it only touches the x-axis exactly once. So it's possible for a parabola to still have just 1 x-intercept. So it's just got 1 x-intercept. That's at 4, 0. And one other thing that we discovered in class is that some parabolas actually don't have an x-intercept. So if I start turning around before I reach the x-intercept, here are a couple examples, I might have no x-intercepts at all. So a parabola can have 0, 2, or 1 x-intercepts. And the very last part of this is we've got some synonyms, words that mean the same thing. So zeros and roots are just different words for x-intercept. So I'm just going to write the exact same thing here. So I have -1, 0, and 8, 0. So we just have multiple words to refer to the same concept. So in class, you're probably going to hear me use all of these. So where we cross x-axis, we can call it the x-intercept, but we also now are going to call them zeros and roots. We're going to talk about where those words come from, and then the only thing we're missing on our note is the y-intercept is where it crosses the y-axis. So just like we learned a lot of vocabulary to describe lines, we're going to be using this vocabulary over the next couple months as we work on parabolas. Your homework or your task, I think most of you completed this in class, is to kind of fill in these pages where you're describing parabolas. And again, you can find filled in copies of those on our course website. So again, let me know if you have any questions as we step into this kind of wonderful world of parabolas. Okay, thanks for watching.